Metals are found on the left side of the periodic table. Metals tend to form cations, which means they tend to lose electrons. Some metals lose 2 electrons, some lose 1, some lose 3, but in general, metals tend to lose electrons. Metals have several distinctive properties. One is they are lustrous, that is, they have luster, which means they're shiny. Metals are also ductile, which means that they can be pulled into long wires. Metals are malleable, which means they can be hammered into shape. And the last property of metals is that they're good conductors of heat and electricity. Now there's a very good reason why metals have these properties, and we'll talk more about that when we get into bonding. But in case you can't wait that long, it has to do with the fact that the valence electrons in metals are not confined to any particular nucleus, but are free to move throughout the crystal structure. And this movability of valence electrons metals all of these properties we see here. We said that the metals are on the left side of the periodic table, which means the nonmetals, in general, are on the right side of the periodic table. We said that metals tend to form cations, meaning they lose electrons. Well, nonmetals tend to form anions, which means they gain electrons. Again, some nonmetals tend to gain 1 electron, some tend to gain 2, etc. But in general, nonmetals tend to gain electrons. A couple of the distinctive properties of nonmetals, for one thing, they tend to be good insulators, whereas metals are good conductors. Whereas most metals are solids at room temperature, nonmetals could be gases generally, or they often tend to be brittle solids as well, although there is liquid at room temperature, and that would be bromine, and there's a picture of bromine here in the lower right corner of the screen. So all of these are nonmetals. The noble gases are, of course, gases, and we have a couple of brittle solids that are shown here, sulfur and iodine. And then there is one nonmetallic liquid at room temperature, and that would be bromine. The metalloids, or semimetals, are a stair step of elements located between the metals and the nonmetals. We've said that the metals are on the left side of the periodic table, with the exception of hydrogen. Hydrogen in the upper left corner is a nonmetal, and you need to know that it is a nonmetal. But aside from hydrogen, the other nonmetals are on the right side in this more or less triangular shape of elements. Those are the nonmetals along with hydrogen. The elements at the bottom, which we sometimes call the F block, or the lanthanides or actinides, which we'll get into later, those are also metals. So you can see just at a glance that the vast majority of elements are metals. There's a little bit of debate, a little bit of argument as to exactly which elements are metalloids, but these are the ones that I consider to be metalloids, and if you want to argue with me, I won't argue back. Some people consider astatine, which is right down here, to be a metalloid, and that's fine. The point is that the metalloids are between the metals and the nonmetals. So the properties of metalloids are not really metallic and not really non-metallic. They're kind of both. Well, if nonmetals are insulators and metals are conductors, then metalloids are kind of semiconductors. They'll conduct electricity in certain situations and won't in others. Of the metalloids, the most important one that you should know is silicon, which is used in the making of computer chips and has contributed greatly to technology. So that one might end up on a test sometime, that silicon is a metalloid. So here's periodicity trend number 2. We can see here again that the nonmetals are on the right, the metalloids are in between the metals and the nonmetals. So metallic character increases going down and to the left. Or another way of saying that is that non-metallic character increases going up and to the right.